Hello, you're welcome to SolidWorks simulation. We're looking at static simulation and design study. But in this video, we'll be talking about static simulation only. We have a wall bracket to support load. We have the load hanger and a pin that connects the load hanger and the wall bracket. And the mass of the wall bracket is 96 grams, very small. The material to be used is an nailed steel, and the thickness of cantilever bracket is 3 millimeters. So we have the thickness of that bracket here as 3 millimeters. Design objective is that the maximum or the mass of cantilever bracket should be a maximum of 150 kilogram. A maximum load on hanger should be 400 kilogram, and minimum factor of safety should be 1.2. Analysis for our study is static. So we'll move over to SolidWorks. We have our material specified here under the brackets as AISI 4340 steel annealed steel. We would go to a new study under simulation tab. Under the simulation tab, we would go to the new study and select static option. Here we usually work from left to right. We have applied material already. All our components have been given materials. A fixed geometry, a fixed geometry fixture will be placed on or will be placed at these cylindrical faces, because the bolts, there will be a bolt going through those circular faces or cylindrical faces to hold the wall bracket in place. So we have that, and our external load would select the force on the load hanger, and that force is 400 kilogram. That's one. 400 kilogram. We'll also apply gravity, which should go downwards that way. Now for connection advisor, we'll be selecting components contacts such that SolidWorks is able to identify contacts between pairs of components. Load penetration. We would now create a mesh and run the simulation. But creating the mesh, we would select mesh parameters and curvature based mesh, so that we have finer meshes in the smaller areas or more intricate areas. We have this, then we run the setup. So the simulation has been done, and the result that comes up first is a stress analysis from MISIS stress analysis, and this is the chart that gives you the variation of values or variation of stresses on each of the components or the model. And we also have a displacement result that shows the resultant displacement of parts of the model. Then we also have strain results. Also, we can include a factor of safety results. Can include a factor of safety result by clicking on result advisor, clicking on the arrow below result advisor, new plots, and factor of safety, and then we will be click that, and we have a factor of safety or minimum factor of safety of 0.0 0.75, which is less than 1, and it's expected that the all brackets will fail. For us to have a better distribution, we can change some of our options or settings, chart options, and then we can decide to make the minimum value 0.5 and the maximum value say 10. So we'll have a better distribution of or color distribution for the factor of safety, and we can also include the minimum factor of safety by going back to our chart options and in ticking this section, show minimum annotation, so we know exactly where um, we have the minimum factor of safety and where the model will likely fail. So if we want to have a better model, it only makes sense to probably increase the thickness of the bracket such that this point will be able to take the load that comes or that is transferred to this area or region. So that is simple stress analysis in SolidWorks, and you can generate a report by clicking on the reports button, and you can include the different sections the report should have, and when you publish it, you have a report in HTML which you can send to a Word document or a PDF document. That's all for static simulation. Thank you.